Hello folks, we come to this new exercise 5.4, and this is going to be a part 1 video in which we are going to take up problems where we have exponential functions. Nothing new to us. When we had studied the formula in the initial part, we had seen what is exponential function and how its derivatives are. Derivative of e raised to x is e raised to x, and derivative of e raised to ax is a times e raised to ax. We have learned all that, so accordingly we will do it. And of course it's not given directly. There are places where you have to use chain rule or quotient rule or product rule and then get the answer. So right away we can start. Our first question says that it is e raised to x by sin x, so it's a quotient rule. So first let's start with let's call this function as y, and because we find it as a quotient, let's give it like u as e raised to x and v as sin x. Therefore y becomes u by v, and we know that by quotient rule dy by dx is, I should have found the derivative there itself. Just pardon me for that. I just get the derivative there, and so that later it's not really difficult. It is e raised to x itself, and derivative of v is cos x. Therefore y is u by v, like that. Dy by dx by quotient rule will become v times du by dx minus u times dv by dx by v squared, and let's take it sin x e raised to x cos x by sin squared x. So we have e raised to x here, sin x minus cos x by sin squared x. That's it. That is the derivative of y with respect to x. That's how we get it. Next question is e raised to sin inverse x. Now sin inverse x, e raised to x we know is e raised to x, but e raised to a function we don't know. So that is why we'll use a substitution and then use chain rule and get the answer. So we'll have it right away. Y equal to e raised to sin inverse x. Let y be equal to e raised to sin inverse x, and for our convenience let's call u as sin inverse x. So what happens to our v value, a y value, it becomes e raised to u. It is more simpler to handle. Like that you will find the derivative of du with respect to x. We know it is 1 by root of 1 minus x squared. Y is in terms of u, so dy by du is e raised to u. Like that we can find dy by dx by chain rule. It is dy by du into du by dx. So let's substitute the values. Dy by du is e raised to u, and du by dx is 1 by root of 1 minus x squared, out of which u we know is our creation, so we'll get it back e raised to sin inverse x by root of 1 minus x squared. So only that much. That will help us to get across to the third problem very quickly. E raised to x squared. Now this problem is important because it's coming later in the exercise also. So let y be e raised to x cube. We are using it later in the exercise as an extension, so it's from that angle it is important. So for our convenience, let u be x cube, and therefore y becomes e raised to u. So u in terms of x, if you take the derivative, x raised to n has got the derivative nx raised to n minus 1, like that. This has derivative 3x squared, and dy by du it has got the derivative e raised to u, like that. When we go into find dy by dx by applying chain rule, it is dy by du into du by dx, and when we get the values, it is e raised to u into 3x squared, or it is 3 e raised to x squared x cube, sorry, 3 e raised to x cube into x squared. We are reverting back. Then u is our creation, so we are reverting. So I'd just like you to note this, because as I said, we see it in elsewhere in the exercise, so we should know this. E raised to x cube has given us the derivative 3x squared e raised to x cube. Now how did we get this? We wrote this e raised to x cube as it is, and we have written the derivative of 3x squared. That's how we have got it. So we can generalize it. What should be e raised to x squared? It will be e raised to x squared, and derivative of e raised to x squared is 2x. What will be e raised to x raised to 4? it will be e raised to x raised to 4, and this is 4x cubed. Why? Because we are taking the derivative over here. E raised to x raised to 5, what would it be? It would be e raised to x raised to 5 and 5x raised to 4. Why? Because a derivative of x raised to 5 is 5x raised to 4. How we get it? We get it by this generalization over here, right? So, and this is, as I said, coming somewhere later in the exercise. So we will directly use this. We'll say that from problem 3, and we can take the derivative directly. And in the exam also, when it comes, you can do this part, any one part properly, and the other part you can say similarly, and then you can extend it. That way you can do it, and then you can use it in that problem. So that's how it is. So that is why we will be using it, and that time we will refer that it is from problem 3. Let's go to the problem number 4, which says that sine tan inverse of e raised to x, many functions. So let's call this function as y. And in order to simplify this function, let's start from the innermost function y. U is e raised to minus x. Then v is tan inverse of u, and y will become sine v. So let us see now how we are able to do this. We'll have u with respect to x. The derivative is minus e raised to minus x. We have to account for the minus. It's like minus 1x. So we have learned that e raised to ax is a e raised to ax. So like that, you have to account for that minus. Then dv by dx is v with respect to, dv by du, because v is in terms of u. Tan inverse, we know the derivative is, when it was x, it is 1 by 1 plus x squared. So here it is 1 by 1 plus u squared. And y is in terms of v, and sine has got the derivative cos. So like that, you've got all the derivatives now. And dy by dx, we carefully apply the chain rule. Dy with respect to dv, dv with respect to du, and then du with respect to dx can very well give you dy by dx. And all these values we will substitute it back. Dy by dv for us is cos v. dv by du for us is 1 by 1 plus u squared. And this is minus e raised to minus x. We are done with that, except for that fact that v and u are your creations, so you have to get back to x or y or whatever it is. So cos v means it is cos tan inverse of, this is cos tan inverse of u, and u is e raised to minus x. So this is done. And by, it is 1 by 1 plus u squared. So u for us is this. So e raised to minus x whole raised to 2 into e raised to minus x. Minus is also there. That's it. You can have the terms coming up here and do it, and that's a derivative of this. So that's our 4th problem. Yeah, with more problems, maybe we can come in the next part. Thank you.